are in listen-only mode.
Good afternoon and welcome to Developing Software for Change, Enter the World of Microservices with Confidence with Matt Pierce. Before I hand over, just a brief note on eSynergy Solutions. eSynergy specialise in open source and cloud resourcing. If you're looking for a new opportunity or to build out your team, please get in touch after the webinar. Now, moving on to some housekeeping. If you have any questions for Matt, please fire them over via the question box throughout and Matt will answer them at the end of his talk. We are recording the session and the slides and recording will be made available and sent to you tomorrow by email along with my contact details. Now I'm going to pass over to Matt to begin the talk.
Hi, welcome to today's webinar entitled Designing for Change, Enter the World of Microservices with Confidence. I'm Matt Pierce, the makers of NetKernel, the world's most innovative microservices platform. Thank you to our host, Alexander from eSynergy Solutions. In today's session, we're going to be looking at the effect of organizational change on the architecture of software, and in particular we're going to look at an emerging trend called microservices. Just a disclaimer, we won't have time to give an exhaustive overview today of microservices as it's a burgeoning area, so instead we'll just focus on understanding business change drivers and some microservices patterns. So onto our topic of business change drivers, let's begin with a familiar example of a publicly listed company called Acme Inc. And Acme Inc. is making specialist stuff for specialist people around the world. And their main rival is Widgets AG, who own 40% of the Asia market, and they're also seeing that their market share is being chipped away by some new market entrants, small virtual internet startups who are luring away customers with better online service. So we're going to join the Acme board as they're planning their strategy for the forthcoming quarter, reviewing their revenue and cost predictions for this quarter in light of their annual targets. The business leaders decide that they need to make more revenue, cut costs, while also dealing with the risk of revenue loss from new entrants. And to top it all, there are some regulatory pressure which they're facing from legislators to which they must comply. So thinking about the ways they can achieve those goals, and finally evaluate the strategies which will be most effective in contributing to those targets, will effectively give them a list of business requirements. So as a global retailer, Acme has 4 primary concerns: planning, buying, shipping, and selling. And it also has corporate functions. It needs to manage the financing, commercial contracts, human capital, and real estate and property portfolio. So from this point, we have some business requirements, and they must be executed by the CIO within a finite time span in order to ensure the continued success of the company. So let's look at the impact of the required change on the business systems of Acme. So aligned with their business activity, some of them on-premise, some of them in the cloud, and what's common to those systems is that they have interfaces, whether human interfaces or system interfaces. They have business logic, and they have information that needs to be processed all day, every day, around a year. So let's look at what's changing a lot. Operational data is changing every second. Since Acme is based around the world, its sales offices and its customers wake up every day, and there are transactions being made which follow the sun. And we also have reference data, which is lookup data, which is the processing of operations. For example, foreign exchange rates, tax compliance rules, shipping rules, supply chain inventory levels, stock thresholds, and so on. And let's just move on to some of the systems themselves. So, we have a number of different application systems, which at the beginning of Acme's life cycle probably started out as discrete, what we call monolithic systems, which had a very specific purpose and probably did what the name on the tin said. So they would have warehouse management systems for managing warehouses, product catalog for their products, and so on. So as Acme as a company grows, and it grew quickly in the last 10 years through acquisition of other companies. Those other companies had very similar sorts of systems, and some of them were merged systems. Others of those systems were allowed to run in parallel. And overall, what happens then is that they may have multiple instances of different system which need to be integrated together. And as far as we know, they might have 4 product catalogs. So the problem is that over time, as new change comes, as has come for this business quarter, new requirements emerge, and we can never turn off the budget for these systems because we constantly have to maintain them, and we probably need to move those specialist skills offshore, where it may be cheaper or more tax efficient to put those skills. So what the CIO would really like is a modular architecture, an architecture which is not defined by the principal function of the application, but is broken down into smaller pieces that it could be changed independently of one another. So we might call that a modular architecture. So one of the classic reasons why modular architecture has not really become dominant is because monolithic systems have one great benefit, which is that they're easy to deploy into production. So they're complex to change because you might want to change a small piece of the system which has side effects and impact on other areas of the system. The more modular and independent that you make the functions in the application, the easier it is to change. But the orchestration and deployment of the system becomes correspondingly difficult. So the key thing is that we would like to have the best of both worlds. Now, one of the common architectural patterns that's thought about, and Acme CIO, when she started, was a small talk programmer, so she was very familiar with Dr. Alan Kay's examples of actor pattern. So essentially what's happening here is we've got elements of state which are waiting for messages in, and when it receives a message, it's processing and changing the state, and then emitting messages out. So that then becomes a discrete system. So is that what microservices is? Well, to some it is, but I'm going to just show you something completely new. So if you just bear with me. Right, so we talked about the modular organization of code. Obviously, many of you will be familiar with the object organization of code, which in effect is very similar to the Smalltalk idea of message passing between stateful objects. Then I want to talk to you about resource-oriented endpoints. So many of you will already be well familiar with RESTful interfaces, which are commonly used for the web. And what we often see within, say, a RESTful API is an endpoint, and behind that endpoint we still have organization of code as objects. In parallel, of course, we have the World Wide Web, and we have that move towards semantic web, things like RDF and other types of integration technology, which in fact sort of spawned HTML, like Signal and XML. One of the things which is really interesting about the World Wide Web is its resilience to change. So again, many of you will have been coding on the World Wide Web for many years and will remember how it was then versus how it is now. It's a very adaptive architecture. So the question then for me is, can we actually look at a different way of organizing the architecture where the resource-oriented service endpoints actually continue into the application code? So the way that we do this is we look at creating an abstraction, and the core abstraction is a generalized version of how the web works. I'm going to just spend a little bit of time to explain this diagram, but once you understand this unit, the rest is just a repetition of this core abstraction. So we start with a requester. A requester is asking for a resource or a representation of a resource. So to explain what I mean, a resource could be the latest message in a message queue or message bus. It could be a piece of data from a database or a result set. Really, a resource could be anything. It could be a file on disk. And that resource will be requested by the requester through the medium of an endpoint. And in fact, what the requester does is it just simply asks for the resource as an addressable resource. And so within a set of abstract resources, the requester will make its request. And then what we do is we resolve that request to the appropriate endpoint. And the endpoint is then responsible for providing and possibly transforming the resource in order to give the representation that's necessary back to the requester. All of that is done within a boundary known as a space. So this is very similar in isolation to the way that the World Wide Web works. But what we're going to do now is we're going to apply this, and probably one of the key things for you to take away from this is that we are bounding this with a space. So the World Wide Web is just one big open space with nominal separation, but effectively it's a big publishing system with one space. That's not very suitable for software. We want to have boundary conditions. So let's look at the way in which the resource is resolved. And the way that we do this is we take the requester, which is resolved to the endpoint logically, and that endpoint could exist within the requester's space, but it could also exist within a separate space. So the resolved space is invariably in a different space from the requester. And then the second part of that is the execution phase. where the representation of that request is returned to the requester. So physically, so that was the logical explanation. Physically, how we're doing this is we have a kernel. And so the requester is actually sending the request to the kernel, and the kernel is then resolving the request on our behalf. And then secondly, what's happening is that request is then resolved to the endpoint, and the representation is passed back. So that's mediated through the kernel. Both the requests and the representations can be cached, and what emerges from that is a very fast system with the ability to actually avoid executing code on the endpoint as far as possible. So wherever there is no change in the system, the system is responding very, very quickly. And it turns out that the amount of change, once you start to organize your software according to spaces, the amount of change is reduced tremendously. So that brings us back to this idea of resource-oriented service endpoints, that we're starting to replace the organization of objects and stateful objects with stateless representations, and the representations themselves are immutable and therefore easy to independently change. So one of the other interesting concepts is that when we make a request, because we have this idea of multiple spaces, we can make the requests with all the context that the request has come from. So a requester may have made a request to an endpoint. That endpoint itself could issue another request, and that new issued request would have the context from the previous request. So, for example, if you requested me to make you a cup of tea, if I had the context of your tea preferences, I would be able to quickly serve you a cup of tea as you like it, with milk or sugar appropriately. If I didn't understand your context, then I would need to ask you that. But once I'd asked that, then you'd given me the answer. Second time you asked me for a cup of tea would be much quicker. So this superstack pattern is extremely useful in separating the concerns of code, because in fact we can make a request from C to D, but we can then travel back up the superstack and get to another space Q, which is just chained together in this pattern. Although I should point out that the only time that these spaces are bound together is when the request is made. So in fact the spaces are completely decoupled and independent of one another. So there are many interesting patterns that can emerge from this. Is a really basic one. So I could make a request for a file set, and that just loads the file from the system. That's called mounting. I could import from different spaces, which I guess you could think of as a way of sort of a bit like dynamically linking code, except there's no linking. It's happening in a completely decoupled way, just like the web is. So what I mean by that is when I make a request, for example, on the web for the Google homepage, I'm not responsible for what gets served up on the Google homepage. So that is completely decoupled, and the people responsible for that are Google, not me. So here's another pattern that emerges where we create a wrapped space, and this is a very useful engineering constraint where I can make a request to a host space, and I can only get to that wrap space through the host. and that's what we call an overlay, because it's a way of encapsulating that wrapped space. So there are many examples where you would want to get access to a resource through a microservice, but you only want to go through that microservice. You would not want to have other requests accessing that same resource. Here's a more complex example of an overlay which has pre-processing and post-processing. So what that allows us to do, if we think back to the processes that that our CIO needs to address, that's planning, buying, shipping, and selling. If the selling and marketing department came up with a new service that they need, we can actually build that upon internal services. And therefore, if we wanted to have, for example, the ability to send messages out to social media platforms like Twitter or Facebook, we could do that by creating some domain services that actually reuse internal services. And here, what you're seeing is actually a certain syntax called an active URI syntax, which is much more like a programming interface than, say, pure REST. So with REST, you have the HTTP verbs. With this approach, resource-oriented architecture, we have the ability to call a certain address, active Twitter messages with the appropriate operands which are passed in. And what that then allows us to do is to combine resources in such a way that a new, richer representation can be served back. And then we can also simplify some of those services which are bound with active URIs to much simpler RESTful types of resource addressing, which, as you can see here, just following almost like a Unix file system or a web URI type of slash page slash customers. And the HTTP protocol could be mapped to that abstract resource identifier through a simple HTTP bridge. And then the other thing that we can do is that once we create these spaces with microservices in, we can then put engineering constraints around the routing. So as we make a request for, say, the resource called page customers, that will then be routed through the appropriate request stack, and it could have an engineering constraint applied to it. For example, it could be audited, which means that every request going through that overlay is audited and logged, and could be traced back to an individual user agent or machine or single sign-on. Similarly, we could throttle. So where there's a system where perhaps we don't want to send multiple concurrent requests, we could throttle it to a certain number, and that's another example of an engineering constraint that we can easily apply. Okay, so that's actually all I'd like to show you today. Hopefully you agree with me that it's something perhaps quite new from what you've seen before. And in terms of follow-up, we're very fortunate and grateful to be working in partnership with eSynergy Solutions. So there are a number of resources which we'd like to make available to you if you have interest. Oh, sorry, this is just one more that I can show you. So here's one other pattern, slightly more complex pattern, and the idea of this is to be able to create read and write separation into the databases. So if we come back to our CIO's problem, one of the big issues that she would have is having all these point solutions with different databases, Those databases may be ETL'd into other databases or data warehouses, and we need to get some read-write separation and some understanding of the normalization of data across the whole estate. So it's very, very simple using basically the same core pattern to separate the routing between read and write, and we can create virtual dependencies, effectively virtual resources that exist outside of our microservices ecosystem that then sort of hit physical connectors into databases. So I was just saying that we're fortunate to be working in partnership with eSynergy Solutions. So there are a number of resources which we would love to make available to you. For example, one of the patterns that we work on quite a lot is the sharing of data. So what we call multi-party secret sharing. And this applies if you're building systems like procurement systems or auction systems or any kind of system where you don't necessarily want to allow other parties to see all of your data. We also have, sorry, if you just bear with me a second, I'll go back to that. We also have 1-day and 2-day workshops which we're running in conjunction with eSynergy, which allows you to get hands-on with code and architecture sessions with us. We can also do that through virtual seminars, and so I apologize for this. And then we also have books available with, for example, by Brian Sletton, who's a resource-oriented architecture. And if you'd also like to get involved in our open source participant community, that'd be great. So that's all that I have to share with you. But if you have any questions, then please feel free to ask them, and I'll try to answer them. Okay, so I have one question related to asking whether NetKernel is a proprietary system. Is there any other way to achieve this? So the short answer is that NetKernel is the only way that I know to construct these sorts of architectural patterns. But microservices is an area which is always innovating, and you know, I hope to see all sorts of different ideas emerging. The key thing for me is that when I look at microservices as a whole, the area which I think is most promising is the kind of RESTful and resource-oriented type of architecture, because it's my belief as an architect that if we continue to use kind of stateful approaches to put code together, it's always going to limit the amount of scaling that we can get from an application, because you're needing to basically to synchronize the state, and synchronization is the antithesis of, or the anti-pattern, if you like, of performance. So I hope that answers your question. So NetKernel is available on an open source license. There's also an enterprise edition which is available on a proprietary license with support as well. So you have the options. Again, feel free to ask any further questions. Okay, so the today's session will be recorded, so if you'd like to look at it again, you're most welcome to. We'll follow up and send the details out where you can reach the video recording. Thank you very, very much for your time, for attending. I hope it's been useful, and if you think of other questions later that you'd like to ask, feel free to come back and ask them. Thank you very much.